Good day, everyone, and I'm going to continue the discussion about electricity and magnetism. Today, I'm going to show you how to build what I believe to be the world's simplest electric motor. And it's so easy that anybody can do it, no matter how uncomfortable you feel with science, electricity, or whatever. I promise you, you can make this electric motor work. Now, the things that we need to make it work are, we need about a 6-inch piece of wire, as I have right here. Something else that we need to make it work is, here I have a small disc magnet, not much different than the size of a dime, just a little bit thicker than the size of a dime, but not quite as wide in diameter. Now this is a rare earth magnet, so this is a very strong magnet. And to do this experiment, we really need a rare earth magnet. It doesn't work very well with a weaker magnet. Now, where can you get these rare earth magnets? Because they're the coolest magnets. I got mine online, and so if you get on a search engine such as Google and type in rare earth magnets or rare earth disc magnets, I found several websites that sell them. Find a high-end hobby store. My experience is that most cities will have one or two high-end hobby stores that might carry rare earth magnets. They come in all different sizes and shapes, and they're pretty neat things to have around, because I'm going to do several experiments with these rare earth magnets. But today we're going to build a very, very simple electric motor. Now, in order to make this work, we're going to use something that's called, in physics, is called the Lorentz force. Now, let me explain how that Lorentz force works, and then I'll show you the electric motor. The Lorentz force works like this. Now suppose that what I'm showing here, you see I'm using the spool of wire, and we'll take the top of the spool of wire to represent the surface of that disc magnet. The magnetic field out of that disc magnet is going up and down. So it's coming right out of the magnet and going up and down out of the disc magnet. So the magnetic field's pointing vertically as in the direction of this pencil. Now, if I can make a current that goes from the center of the magnet out to the edge, so I want my current to go like this, my magnetic field goes like that. Now the Lorentz force says that if I have an electric current moving through a magnetic field, that there is a force generated that is perpendicular to both the direction of the electric current and the direction of the magnetic field. In basic physics courses, this is sometimes referred to as the left-hand rule. So here I'll take my fingers and I'll represent them like this. Whereas if the direction of the current is going out this finger, and the direction of the magnetic field is going along this finger, the force imposed on those electrons is going like this. Okay? So that's called the left-hand rule. Now let's see how we can utilize that left-hand rule to make an electric motor. So here, actually I have two disc magnets, and it's going to be a bear, because they're stuck together, a bear separating them, so I can just get one disc magnet. It's hard to do, as you'll discover. Take a screw or a nail. It has to be one, again, made of a magnetic material. Iron or chromium steel. Aluminum won't work, and many types of stainless steel won't work. Copper won't work. So it has to be a magnetic material, because it needs to stick to the magnet like that. Okay, now I have a AA battery. Okay, just a small AA battery, but I could also use another size battery, will also work. But the experiment is probably a little bit more impressive if you do use everything small rather than something big. And then because now this screw is a magnetic material, the magnetic field is concentrated in the screw, and I can hang the tip of that screw right off of the end of the battery like that. Now, the reason why this is important here is because that tip of the screw just touching the end of the battery makes it so that it's easy to spin the screw. That connection there acts like a very low friction bearing. Now I have my wire, my 6-inch piece of wire. I'm going to hold one end to the top of the battery. Now the second end I'm going to take around to the side. I'm going to touch the side of the magnet. Because what I'm trying to do is I'm trying to get the current from the battery to go down the screw into the magnet, and then from the center of the magnet out to the edge. So that's how I get my current traveling from the center of the magnet out to the edge. The magnetic field from the screw, or from the disc magnet, remember, is already going up and down. So I'll get electric current moving from the center out to the edge. I have magnetic field going up and down, so that means that the force generated here from the Lorentz force, or left-hand rule, is a tangent along the edge of the magnet. Now the force along the tangent, the edge of the magnet, will cause it to spin. Now watch as this thing spins. If it spins too fast, you can't see it. Of course, if it spins too slow. Now, like I said, you can also use a big battery if you want. The size of the battery, the only thing the difference the size of the battery makes is that it'll last longer with a big battery. So that is the world's simplest electric motor. Now, if you get that really going, if you just hold that there for a few seconds and get it really spinning, that thing can spin really fast. It'll go 10, maybe 20,000 revolutions per minute. It really goes fast, and I think you're going to enjoy that. So, thank you very much. That's our experiment in doing an electric motor.